My name is Ben. Today we're going to be talking about linear data structures. Now, if you're not a Java guy, that's totally fine. The fundamentals of how these things work will be useful in all languages. So let's get started. Let's recall what a list contract is. A list should be able to add an element, insert an element, remove an element, set a particular spot in the list to be a value, identify whether or not the list contains an element, and get the size of the list. Now, an array list is exactly like what it sounds. It's half an array and half a list. It's a portmanteau, which means a mashup of words. It's a portmanteau of an array and a list. Let's break that down a little bit more. An array, we already know, is a piece of memory that is whatever data type you choose times whatever length you choose of the array. But a list is a contract. So deep down, an array list is truly an array, but wrapped in an object or a class that satisfies the list contract. So now that we have our contract, let's describe how these functions should work for an array list. So my apologies, I just realized after making this video that I missed one of the most important parts of the list contract, and that is the get. And the get behaves as basically an array access. So given the numbers 1, 2, 3, 4, and 5, and they're stashed in a list, I want to get the first element. I use ArrayList.get, which consumes the index. So in this example, ArrayList.get 0. And because this is powered by an array, we get to look up this piece of memory in constant runtime, O of 1. Let's talk about adding to an array list. So array lists, they usually initialize with some non-zero length here. So in our case, the array list is going to start with a size of 3. And we are going to add the numbers 1 through 5 to this array list. So when we add number 1, we're going to put it in the first slot of the array. We add 2, it goes in the second slot. We add 3, third slot. Now when we try to add 4, we can't add it to the slot because there's no space left. The array list will then create another array of a bigger size, in this case 6. Then it will copy over 1, 2, and 3 from the previous array and place them in the new array. Now we have room for inserting 4. And we also have room for inserting 5. Let's analyze what just happened here. For a majority of our adding to the array list, it was a really quick set. We just went into the array and set a piece of the array, an element of the array, to a number. But every once in a while, we have to do an extremely lengthy process compared to just a regular old add. We have to create a new array that's of a bigger size, and we have to copy everything over. This concept of having a worst runtime of generally something not that bad, and then having once in a while an even worse runtime is called amortized time. For an array list, the amortized time is O of n. It's linear because you have to copy over all of the elements from the old array into the new array. However, if you're not doing that copying, it's a constant time runtime complexity. But one thing to be aware of when you're figuring trade-offs here, if you grow too aggressively with your array list, you'll have empty spots at the end of your array list that are not being used, like you'll see in the example we have here. But if you have the sort of factor of which your array list grows by to be too small, then you will incur this amortized time more often than you would want to. The old array will simply not be used anymore, and depending on the language, it may be deallocated, called, or removed. Now let's talk about a little bit of a different use case. Let's talk about inserting a value into an array list. And let's make it the worst possible thing we have to do. Let's add a number to the beginning of the list. What's going to happen is this 0 needs to be living at element 0.
So the array list will then have to copy or move down every single element or every single value in the array list down one, and then it can set element 0 to value 0. This means that worst case runtime complexity of an insert is going to be O of n. Now, to make matters worse, this insertion may cause that amortized runtime to happen. If we were to add another insertion at 0, we would be too big for this array, and we would have to copy everything over to an even bigger array. So be careful and realize that insertions and adds, anytime you're adding contents to an array list, can cause that amortized time runtime. Now that we've talked about insertion, let's talk about removing an element from the array. Again, let's choose the worst possible element to remove, just to show the point. Given the list of 0 through 5, remove 0. What will happen here is everything past 0 needs to go up 1. So we don't really do any deletions, but we kind of overwrite 0, and now we have one empty space at the end of our array list. This is not subject to amortized time, thank goodness, but still it is a O of n, a linear runtime complexity, because we have to move every single element upwards. Now when we're trying to set an element with an array list, we actually are really lucky, because if you recall, setting a piece of memory in an array, it's constant time. So if we have the list 1, 2, 3, 4, 5, and we set element 1 to -1, the set is going to be constant time, and it's going to be extremely fast. This is why having an array powering this list is kind of helpful, because you get the benefits of array gets and sets runtimes. So let's talk about when an array list contains an element. We can ask the array list if it contains a particular value. So given the list 0, 1, 2, 3, 4, 5, 6, does 6 appear in the list? Now the way we do this is we have to for loop over every element in the list, which means that the runtime is O of n. It's linear. By the way, this is the same runtime we have if we're just searching through a regular old array. When we are asking an array list what size it is, as an example from 0 to 5, we ask the array what the size is. Well, we have these two concepts of sizes. We have the size of the array and then the size of what's in the array. So as an example, if you have elements at the end of your array list that are not being used, that is called a different name. I believe it is called capacity. And the last element in your array list plus 1 is the size. So obviously when we're asking an array what a size is, we can just have an attribute of the array list be the true size plus 1. And we can control that when we insert, delete, or add an element.
So as you can see, array lists preserve the array, so they're really fast for getting the information out of the array and setting the information in the array. But keeping the array list in order, if the array grows too big, or if you're doing a lot of insertions or deletions, is kind of expensive. I hope you enjoyed this video. Please like and subscribe, and show us to your friends.